Hi, everybody. Welcome to my channel, Numbers with Nora. This channel is all about math, tutoring, and helping everybody with their math needs. For this specific video, we're going to be doing geometry, chapter 3, 3.1, parallel and perpendicular lines. The book that I'm using as a guide for this video is Larson Geometry by Ron Larson. There's also going to be a free download in my channel as well if you want to follow along. But if you're using another book on this topic, then you still will be able to follow along as well. All right, so let's get on with the lesson. So the objective of this lesson is identifying angle pairs formed by two intersecting lines. And the first thing we're going to go through is vocabulary, because with mathematics, vocabulary is very, very important to understand your problems. So let's start with our first vocabulary word, which is parallel lines. Parallel lines are two lines that do not intersect and are coplanar. Coplanar is another vocabulary word that we used earlier on in our chapters, and it just means that two lines or 2 points that lie on the same surface or plane, right? Our second vocabulary word is going to be skewed lines. Skewed lines are kind of like parallel lines, but they're two lines that do not intersect and are not coplanar. So they do not lie on the same line. And we're going to look at examples of these coming up. And then we have parallel planes. Parallel planes are just going to be two planes that do not intersect. All right. So before we go on with any other vocabulary, let's go ahead and look at example 3. Let me zoom in so you guys can see. All right. And for example 1, they want us to identify relationships in space. Think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? Let's do A, and we're going to be referring to this image over here on the right-hand side. So for A, they want us to sit there and identify lines parallel to CD. All right, lines parallel, here's CD. But then there's also another condition, and contain the point A. All right. So first I want to sit there and list out all my lines that are parallel to CD, or we can say DC. It doesn't matter whichever, you can change them around. So all the lines that are parallel to CD, remember parallel are non-intersecting lines that are coplanar. I sit there and see AB right here, right? They connect by this plane right here. So I can sit there and safely say that AB and then for a line, we sit there and use this right here, this indicator with the two lines at the end on top to sit there and tell other readers that we are talking about a line. Another line that I can safely say is parallel to DC is line EF, because they share the same plane right here. So I can say EF. But again, our condition sat there and said containing point A, right? So out of these two lines that are parallel to DC, the only ones that I could see containing point A is going to be this answer right here, line AB. So this would satisfy our conditions for A, right? Let's move on to B. So B is kind of like the same thing, lines skewed. And remember, skewed lines are lines that do not intersect and don't lie on the same plane. It can't touch the same plane as CD. And then our second condition, containing point A. Okay, so let's look at what those would be. So lines skew to CD, I want to look at lines that don't touch this plane. And when I mean plane, I mean like a flat surface like this, and that contains CD, flat surface like this, like the side of my box. And you can kind of look at this as like a keyword box. And it doesn't contain, yeah, just those two. So I would say safely, I can say AG, AG is a skewed line to CD. And I put my annotations. And then also AH. Are skewed in comparison to DC. And again, I look at my conditions and what they're asking us, and they say contain point A. Well, both of these skewed lines contain point A, so I'm safe. I can say both of these are my answers. Right? Let's move on to problem C. So for C, we're looking for lines that are perpendicular to CD. So remember perpendicular? That means lines that do intersect CD, but then at the same time, they create this little box right here, right? And that box indicates that it creates a 90-degree angle, right? So ones that I can sit there and list out that are perpendicular. Again, we do have to remember this other condition, but let's list out all the perpendicular lines first. Perpendicular line that I can see right off the bat for CD is DA. That forms that little box. DA. And since it's a line, I sit there and put the top at the annotation on the top to say a line. And then also CB, even though that doesn't have the box right there, I know because this is a square, all sides of a square are equal. So I can say CB, B, and put my annotation on top. I can also say that line ED will sit there and intersect this line as well, create a 90-degree box right there. So I can say ED. And then I can also safely say FC will intersect DC as well and create a perpendicular line. So FC. But again, we have to remember our second condition, which was containing point A. So we look at all of our perpendicular lines to CD and which one contains A. Only one I can see that contains A is going to be DA. This one right here, which is perpendicular. All right, so now let's do D. So D wants to now know about planes. And this one says planes parallel to plane EFG and containing point A. So planes parallel, remember parallel, they can't intersect and they can't touch at all. For plane EFG, how we name planes is by using 2 points or 3 points, right? So I have EFG. That means I'm talking about this plane, the bottom of my box. Just the bottom surface of my box is what I'm looking at. So I want to sit there and look at a plane that does not touch this at all, but is still parallel to my plane EFG. If I look at the top of my box, this is another plane that does not touch that lower plane at all, but it's still parallel to it. So I can put plane ABC. All right. And that's going to be the answer to that one. Perfect. All right, and let's keep going. So those are our answers for example 1. Let's go on within the section 1.3. In 1.3, you're going to see some other things. You're going to see 2 postulates, all right? And basically in mathematics, postulates are things or statements that are assumed and that you can use in your proofs, which we're going to do later on in the chapters. All right? So let's look at our postulates. So our 2 postulates that we're going to look at are the parallel postulate and the perpendicular postulate. And I will draw these out so we can visualize what they're saying in these. But let's read them first. For the parallel postulate, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. There's exactly one line through P parallel to L. Let's draw this out and sit there and see what they're talking about. So if I have a point P and a line L, and that point P does not lie on my line L, then what they're trying to say is that there's only one line that I can draw through my point P that will absolutely be perpendicular, or my apologies, parallel to P. Only one line. All right. And the perpendicular postulates is very similar. If there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. There's exactly one line through P perpendicular to L. Again, what they're trying to say here is if I sit there and have a point P that is not on my line L, so let's draw this point P. It's not on my line L. Then I can draw exactly one line through my point P that will be perpendicular to my line L. And 2 things I want to note about annotation is perpendicular. We use this square box to annotate that it's perpendicular. And those 2 lines, when they intersect, they are going to create a 90-degree angle. And there are also annotations for parallel lines. They have the 2 arrows on them like this. Sometimes you might see a double arrow like this. And that just indicates that my 2 lines for sure, without you having to prove it, are parallel. Okay, so let's go on to the next section of an example of this. So example 2, what they want us to do is identify parallel and perpendicular lines. Photography. The given line markings show how the roads are related to one another. So let's start with A. And of course, we're looking at the image to our right. Name a pair of parallel lines. So since they give us an image, like I said, we want to look at our annotations. The annotations that indicate parallel are these 2 triangles right here on these 2 lines, on my line MD and my line FE. Since they share those same markings, I know that MD, my line MD, and then we put annotation up here to let other readers know we're talking about a line. To indicate parallel, we put 2 lines like this, parallel to FE. Right. And that's the answer for that one. All right, let's clean this up before we go on to B. For B, they want us to name a pair of perpendicular lines. Remember, perpendicular. For our perpendicular, we have the annotation of this little square box, which means when those two lines intersect or cross, they're going to form a 90-degree angle. So I want to sit there and see what lines are indicated or involve this box. The line BF involves this box, and the line MD involves this box. So I will sit there and say that line BF, and of course we want to keep on using our correct annotation. That's very important. Line BF, and to annotate perpendicular, you do like an upside down T, and that is perpendicular to line MD. Okay. Perfect. So now let's go ahead and look at C. Clean up our image a little bit. For C, it's asking us a question. Is the line FE, FE is right here, perpendicular, that's our annotation for perpendicular, to AC? And it says explain. Now, just from visually looking, I noticed that AC and FE do not have that same kind of annotation that sits there and tells me they're parallel lines. So that's one indicator that I could say no. Another thing, if I just look at them visually, I'm like, they don't really look like parallel lines. They're not like right next to each other. So we can assume no, but mathematically we would have to prove this using one of the postulates that we looked up before. So in our postulates, it sits there and says that if I have a line, our line is FE, and I have a point that's not on that line, point M, I can only have one line sit there and go through that point and be parallel to FE. That one line we already said is this one. I can't have another one going through that, which would be AC. So there's no way that I can have two parallel lines for FE, right? So we can say by, and I'll use the annotation for parallel postulates. And that is why it is false. And I'll put postulate. Good. Let's go ahead and take a second and look at that. Make sure that's good. Good. All right. So let's continue on. And we only have one more example and one more vocabulary word. Another thing in this section that we're going to look at is transversals. Transversals, okay, is a line that intersects two or more coplanar lines at different points. All right. So let's visually think what this means. Geometry is very visual, so you want to be able to see what they're talking about when they're talking about definitions and postulates and soon proofs. Okay. So by a transversal, I mean that there's two lines on the same plane, coplanar. They don't have to be parallel. They don't have to be perpendicular. It's just there's two lines on the same plane. And when those two lines intersect, or sorry, when I draw a line through those two lines and intersects both of those lines, that is called my transversal, and we sit there and mark it with a T like that. Now, when we create this transversal, it creates certain angles that we will be able to identify next. All right. And so let's go ahead and see what those angles that are created by that transversal are. So for the first one, we have corresponding angles. All right. Corresponding angles they have corresponding positions. For example, we have angle 2 and angle 6. These are corresponding angles because they're on the top of each of my line, and they both touch my transversal. All right, that's how you can think about those. For alternate interior angles, remember the words alternate means other side, and then interior means inside. So on opposite sides of my transversal and on the inside of my two coplanar lines, I have these angles. Okay. And then again, I have alternate exterior angles. Alternate means other side of my transversal. Exterior means outside of my two lines. So outside of my two lines, and on the other side of my transversal, I have alternate exterior angles. And then consecutive interior angles. Consecutive means one after another. And then interior means inside. So inside of my two lines and right next to each other, I have my consecutive interior angles, right? So let's go ahead and do exercise 3 or example 3, where we identify angle relationships. And we want to identify all pairs of angles of the given type, right? So let's start with A with corresponding angles. And if you do have to go up while you're doing your homework and look at the chart every now and then, that's fine, but sooner or later you will start to memorize them. All right, let me just make sure I'm not out of time on here. Yep, we're good. And so let's start with A, corresponding. So corresponding angles, like I said, if we look back up at our chart, it's going to be angles that are on top of my coplanar lines, but then on the same side of my transversal. Okay. So these would look like angles 1 and 5. And then also angles 3 and 7, right? Those would be considered corresponding angles. And go ahead and take a second to write that down if you do have pen and paper. But then also I could go to the other side and look at corresponding angles as well. So another would be 2 and 6 or corresponding angles. And then another pair of corresponding angles would be 4 and 8. Okay, see how they're on the top of my two coplanar lines, and then my transversal T, we can annotate that so we know what our transversal is right there, corresponding. Okay, now let's look at B. What would be my alternative interior angles? Right? Remember, alternative means other side of my transversal, and interior inside of these two coplanar lines. So I would say these is inside, 2 is inside, and 7 is inside, and they are alternate to my transversal. So 2 and 7 are alternative interior angles. Another pair of alternate interior angles would be 5 and 4. Right? So those are my two pairs of alternative interior angles. Now let's sit there and look at alternative exterior angles. So alternative, but then on the outside of my two lines. So 1 is on the outside, and also 8, and it's on the other side of my transversal. So 1 and 8. And then I can also look at 6 and 3. 6 is on the outside of my two coplanar lines. And then 3, they're both on like opposite sides of my transversal. So alternative exterior. And then last but not least, we have consecutive interior. Consecutive interior means they're right next to each other, but they're inside my lines. So 2 and 5 will classify as consecutive interior. And then another pair could be 4 and 7 that classify as consecutive interior. And the more you sit there and do these exercises, and we will see these more and more as we go on with geometry, you'll get used to them and be able to identify them fairly quickly. All right, so that's the end of curriculum for chapter 3.1 or section 3.1. Again, if you have problems from the book I'm using or your other geometry books, sit there and write them in the comments. I'm here to help with homework questions, or if you would like further tutoring, please subscribe or leave a message in the comments section. And if you have anything that you need help with math-wise, just let me know. Thanks, you guys.